Hi Year 12, today we're going to have a look at areas enclosed by the y-axis. Now this follows on directly from areas enclosed by the x-axis, and obviously we're just changing the axes now. So our function, here is our function here, and we're given two values of y. So here we've got y equals a and y equals b, and we've got the y-axis. So we're looking for the area that's shaded in here in our graph. So you're going to need to draw our curves and pop in our upper and lower limits of y and figure out what we need to do. Now, like we had in our areas enclosed by the x-axis, we have a positive and negative area region. Because our x values are positive on the right-hand side of the origin, our area that is found against the under the curve and against the y-axis would be a positive area. If we were looking at an area on the left-hand side here, so to the left of the origin where we have negative x values, we would call this area here a negative area. So that's something to take into account and to remember that. So to find the area between a curve and the y-axis, we change the subject of the equation of the curve to x. That is, x equals f of y. And now what we're going to do to find a definite integral, we're going to be integrating with respect to y. So when we're finding the area enclosed by the y-axis, our integral will be with respect to y. And our function won't be y equals, our function will now be x equals. And we need to sometimes change our function in order to get the right outcome. Let's have a look at the first example. I'm going to find the area enclosed by the curve x equals y squared, the y-axis and the lines y equals 1 and y equals 4. Now this is already set up nicely for us. We've already got an x equals, so we don't need to rearrange this equation. So we have an x equals, and I'll just highlight the bits that we want. We know we want it to be the area against the y-axis, and we have our two y values. So we can just pop that straight into the integral now because we know what we want. So I basically want to find the integral between 4 and 1 of y squared dy. It's y squared because our function needs to be x equals and be a function of y as opposed to a function of x. Once we've got all those bits of information in there, we can straight away get our, just basically doing what we were doing before in integrating. Okay, so when we integrate y squared, we add 1 to our index to get a 3 and we divide by that new index, and we're calculating our upper and lower bounds with 4 and 1, same as what we did before. Now let's pop that into our function. So I'm just going to fix up my sheet there. There we go, that's a bit better. Popping 4 in first, we get 4 where our y is, we become 4 cubed over 3 minus our 1 goes in, 1 cubed over 3. 4 cubed over 3 is 64 over 3 minus 1 cubed over 3, which is 1 over 3. That becomes 63 over 3, or 21 units squared. The units squared are important, okay? We're looking at calculating the area. Our area is always in units squared, so you need to make sure that you're doing that. Okay, let's look at the next question. This one's a little bit different. We need to do a little bit of maneuvering with our function here. Okay, so we're going to find the area enclosed by the curve y equals x squared. I'm going to highlight those again for us. Y equals x squared, the y-axis, and the lines y equals 0 and y equals 3. Now, we are going to graph that, but I want to note here that this is y equals x squared. It's not x equals, so we need to change our function a little bit, and we will do that over here in a moment. So let's draw our parabola. So that's our y equals x squared, and it's going to have an area that's enclosed between y equals 0, y equals 3, and the y-axis. So that's our area that's coloured in green. We have y equals x squared. We need x equals because we're going to differentiate with respect to y because we want to enclose by the y-axis. So in order to rearrange that, I'm going to take the square root of both sides, and I'm going to get the square root of y is equal to x. We don't need the positive and negative. We only want to have the positive value of y here. And we're going to pop that straight into our integral. So we're finding the integral between 3 and 0 of y So we'll pop out there. So between 3 and 0, here's our 3 and our 0, of the square root of y, which we write as y to the half dy. So we're going to integrate that with respect to y. When we get that, I'm going to pop it into our little square brackets. We've got our upper and lower limits up here. We're going to integrate y to the half. Let's add 1 to the power. A half plus 1 is 3 over 2. Let's divide by that. Now what we're doing is saying a half to the power, a half plus 1 gives us 3 over 2 to the power. Divide by that 3 over 2. What we're doing when we're dividing by a fraction is we're multiplying by its reciprocal. So what we're doing here is we're multiplying by 2 over 3, which is the reciprocal of 3 over 2. And that's where my 2 over 3 here comes from. So we now can enter in our 3 and our 0, our upper and our lower limits. So we're going to have 2/3, 3 to the 3 over 2, minus, we're going to pop 0 in, everything here goes to 0. So we're basically just left with 2/3, 3 to the 3 over 2. Pop that in your calculator and you're going to end up with 3.46. I popped it to 2 decimal places, units squared. Okay, and that's our little rundown on the y-axis. So I think those are fairly straightforward. That'll allow you to go through the exercise, or I think it's 4G. The main bit here is making sure that your function is in terms of x equals, not y equals.